Hello everyone, it's Rich McHugh, and this week we're going to be covering 3D design with TinkerCad or Autodesk Fusion. This is a quick outline of what we're going to cover today in the presentation I'm doing now and then in the hands-on time after. CAD stands for computer-aided design, and there's a wide range of tools out there with different focuses and different ease of use capabilities as well. Today we're going to be focusing on two. The first is TinkerCad, which is not very powerful but is easy to use and free, but it's not the only tool, as you can see. And the other tool that is Autodesk Fusion. Actually, TinkerCad is also an Autodesk program, but it is a much more powerful tool, and but it is more difficult to learn. So again, no need to use it, but it is a powerful tool as well. TinkerCAD, like I mentioned, it's an easy-to-use tool. It's browser-based, so you don't need to install any software, and it is free to use and was built by Autodesk for educational purposes. It's relatively intuitive to use, and you can create a wide variety of designs using TinkerCAD. And it's easy to access additional tools for coding and electronics, and there are a lot of tutorials. And if you reach a point where you aren't able to do something in TinkerCAD, you can easily export your model to Fusion so that you can do more complex tasks there. Some of the cons to TinkerCAD is that you cannot create complex shapes like hinges or pistons, for example, and it lacks some helpful features like a timeline and precision modeling that you get in Fusion. In terms of pros for Fusion, you have complete control over all of the shapes, and it is a really powerful modeling tool. It gives you a design timeline that you can see down at the bottom here, and there are additional features for drawings, renderings, load simulations, and manufacturing. So if you want a drawing to help you, if it's a woodworking project, for example, you can export a drawing with the dimensions for each of the objects that you cannot do in TinkerCAD, for example. And there's also an app for your phone so that you can view project models in a mobile app. On the negative side, there is a much steeper learning curve for Fusion. It's more powerful but more difficult to learn. And it is free for educational use. And last I checked, it was also free for hobbyists. So which to choose? It really is up to what types of project you want to do. You can't go wrong starting with TinkerCAD and then moving to Fusion, but if you're confident that you're going to need to use Fusion, then I'd potentially just start there. Like I mentioned, TinkerCAD is best for less complex shape and non-organic shapes, and these are examples of things that we cover in our workshop activities. So we have step-by-step tutorials on how to make all of these objects. Again, we order the objects in order of difficulty. So for example, our keychain activity is one of the easiest ones, and then the dice and the box is probably on the more difficult end of the activities. Fusion is better for more complex shapes. As you can see here, there's a ring. There's a plug for a boat that actually I made for someone who needed to replace a plug for their boat. This is a microphone that holder for a wireless microphone that I'll talk about in a minute. And here's a bottle, and you can't really see it here, but there's some branding on the bottle that I put there as well. So here's an example of a problem I solved for myself. We have Rode wireless microphones in the Digital Scholarship Commons, and they're wonderful, but it is helpful occasionally for us to have a microphone holder. So I looked online to see how much these cost, and this was, they're cheaper now, but a couple of years ago when I was looking, they wanted $99 for a piece of plastic and a little piece of foam to put over top. Couldn't bring myself to doing that, but I thought I know how to do 3D design, and we have 3D printers. So I designed and then 3D printed a holder, a microphone holder for it that works quite well. I put it on a website so that other people can download it and use it if they want, and it cost about $5 in plastic. Plus we can make as many as we want or need in a variety of colors. This is another example of a microphone stand holder for our multimedia folks downstairs. They needed to replace, they were running out of them, they were losing them, our patrons were losing them. So I got out the calipers, measured the dimensions, did a sketch, then in TinkerCAD created the model and then printed a whole bunch of them for them. So the design process in TinkerCAD, and this is an oversimplification, but just to give you a sense, basically you'll drag a basic object like a square or a circle or a cone onto the build plate, or onto the build plate, not guild plate, and then you shape it. So in this case I drag the corners to make it into a rectangle, and then I grab the top handle and flatten it down to make it flatter than the original shape was. And then I added some shapes. These are negative space shapes, and then group them together so that it created this shape, a kickstand for my cell phone. That is one example of what you can do. Fusion is a little bit different. You start with a sketch of the two-dimensional sketch of the shape. Then you tell it height, how high you want, and create a feature similar to what we did in TinkerCAD, but it's just a little bit more complicated. Then you sketch other features on the object. So there's the hole in the corner, there's the corner shape, that you can select this shape again and tell it you want rounded edges, and then you've got your final shape. So a little bit different. Again, you have a lot more control and flexibility in Fusion than you do in TinkerCAD, but you can create similar things or create much more complex shape in TinkerCAD. So some things to remember: a design is rarely perfect on the first try, so that's okay, you can try again. And the dimensions of manufactured parts will always be slightly different than the CAD model based on the limitations of the 3D printer or laser cutter. So we'll talk a bit more about that in class, but and I'll show you an example of one that should have worked in theory, but because of the tolerances of the 3D printer, we needed to change the design for a couple of pieces to fit together. And usually there's no one correct answer for designing an object. Just a word about 3D printing and laser cutting. This is a 3D design that we can print on our 3D printers. It would take about 5 hours to print and cost about $6.50, which is fine. By comparison to laser cut it in 3mm plywood, it takes 90 seconds, $1.50 in materials. You do need to assemble it, and you only have one color. But just to remind people that there are you may be able to do something with laser cutting in a way that might be quicker and more helpful for prototyping, comparing the 5 hours to the 90 seconds and then the price. The major negative about laser cutting is that it's more difficult to do organic shapes, and some things you just can't do with laser cutting, but just something to keep in mind. So in terms of the TinkerCAD activities, the easiest ones are the keychain and the cell phone kickstand. Moderate ones would be the game pieces, the box, and the snow person and snowflake. And then the more challenging ones would be the dice, including a loaded die, and the puzzle pieces. In terms of the Fusion activities, the easiest one is the kickstand. Moderate would probably be the pin, designing a pin. And then, again, moderate would be creating some Lego pieces. If you do want to learn more and go deeper into Fusion 360, I have links on the website to a 30-day tutorial on how to use YouTube that I did during COVID and is wonderful, and this will teach you a lot about Fusion 360, and I highly recommend it if you want to go deeper. We offer badges for both. This one is for 3D printing. Actually, we're going to do that next week, so ignore that. But we do have one for TinkerCAD and then one for intermediate 3D design with Fusion. So let's go to the website now for the hands-on part of the class, and we'll talk to you later.